Hi everyone, welcome back to chemistry. So in the last few videos, we've been talking about how ions are formed and what common ions are going to be formed with different atoms, and how we can form these ionic compounds, how they're made, stuff like that. But I don't want to forget about these things called polyatomic ions. They're very important. And unfortunately, you do just have to memorize some of them. So what are these? So polyatomic ions is just kind of like the term sounds like. So poly means many. So these are groups of atoms bonded together. They're sharing electrons, and we'll talk about what that means. But they have an overall electric charge. So for example, looking here at this first one, we have NH4 plus, which is actually our only cation that's a polyatomic ion. And it's called ammonium. So it's one nitrogen bonded to 4 hydrogens, all with an overall charge of +1 or 1 plus. Okay, or just plus, right? If there's no number there, we just assume it's 1. So it's got an overall positive charge. So all of those atoms are bonded together covalently, actually, and we'll talk about what covalent bonds are. But they're all bonded together, but they have an overall charge. And that's what makes this a polyatomic ion. All right, so that's our only cation of the polyatomic ions that you need to memorize, and you need to memorize all of these. So I would recommend making some flashcards. And these ones, right, it's the same idea. For instance, nitrate, NO3 minus. NO3 minus is 1 nitrogen and 3 O's bonded together with an overall charge of 1 minus. Or sometimes just, you'll just see it as minus. NO3 minus. So what I would do is I would write exactly what you see here, and then on the back write the name, okay? Because you need to recognize these. All right, so we talked about the writing formulas for monatomic, single atom ions. So things like, Na plus bonding with Cl minus is going to give us, NaCl, right? Neutral compound because these are canceling out, right? It's the same idea for polyatomic formulas or compounds with polyatomic ions in them. Our overall goal is to make sure that the charge on our final ionic compound is neutral. So what do I mean by that? So let's do an example here. We've got barium, right? Barium's in group 2A, so it's going to form a 2+ charge when it forms an ion. And we've got that written here. And then nitrate is one of our polyatomic ions. All right, so if barium has a 2+ charge, so that's our cation, and nitrate, NO3, has a 1- charge. If we just wrote BaNO3, and I'm going to put parentheses around nitrate here because it just makes it clear that you've got a polyatomic. And sometimes we'll have more than one, and then if we do, that number goes out here. But we'll talk about that. So for barium bonding to nitrate, is this compound that I've written out just like that, is that a neutral compound? No, it's not neutral, right? Because looking here, we've got a 2+ versus a 1-. So those aren't canceling out right now. So what do we need to do? Yeah, we need to add another nitrate. Let's add another nitrate. So we can do that. That's allowed, right? Just like we could add more fluorines or chlorines up above, we can add more nitrates. So this one has a 1- charge as well, right? Nitrate. And notice now I've got 2+ over here, and then 1- plus 1- over here, which is going to be a total of 2-. Okay, and now those charges are going to cancel out. So what do I need to put right here? Yeah, 2. Okay, and now I've written the correct formula for barium nitrate. And that's how you would call this. You would say barium, or write it, nitrate. Barium nitrate. Or, right, this is your cation, and this is your anion, right? Cation always comes first. We don't need to drop this ending here and make it an IDE. Don't ever change the names of your polyatomic ions. They just stay the same. So it's barium nitrate, just naming the anion that we have, or polyatomic anion. All right, so let's practice this. So now we have ammonium and nitrate. So first off, what's ammonium? Yeah, that's NH4 with a positive charge, right? And nitrate we just looked at was NO3 minus, right? Remember, both of these are things you're going to memorize with your flashcards. Okay, so ammonium and nitrate. So when these two bond together, let's see, we've got a positive charge here, and we've got a negative charge here. So that looks like just a 1-to-1 ratio, right? Those charges are going to cancel out. So we can write NH4 and NO3. You'll also sometimes see it just written like this. I'm just putting the parentheses, both of these are correct, but I'm just putting the parentheses there to show you which one's which for your polyatomics. Okay? But we only need one of each, so you could totally write it like this as well. Really important that up here, let me see, up here, you do include parentheses because you have more than one of those polyatomic ions. If you didn't include those parentheses, it's kind of ambiguous and it just looks a little weird because now that 2 looks like it's going to the oxygens, but it's not, right? It's actually saying we have 2 of everything in the parentheses. 2 of everything in the parentheses, okay? So make sure you include those parentheses. Over here, since there's just one of each of these, you don't have to put them on there, but you can if you want to. All right, let's try the next one. So this is magnesium and phosphate. So phosphate is one of our polyatomic ions. So let's look up at our chart and we can see we've got phosphate here, PO4 minus. PO4 minus. So PO4 minus. And magnesium is just our regular magnesium ion. So looking at your periodic table, what's the charge on magnesium going to be when it forms an ion? Yeah, 2 plus. 2 plus. All right, so we've got a magnesium and a phosphate. So right now, looking at these charges, is this going to be a 1-to-1 ratio? No. No, we're going to need more of something, okay? Maybe more of both. So let's see here. So we've got, let's try this over here. We've got magnesium, 2 plus, and we've got phosphate, PO4 minus. I'm going to just erase this to give us a little bit more room here. And we'll just put this as our final answer up there. All right, so looking here, we've got PO4 minus and magnesium. Well, I know I'm going to need more of something. So I don't know, let's just put another PO4 minus. Let's just add another phosphate and just see what happens. All right, so now on the right side, my charge is 3 minus and another 3 minus, which is going to give us a total on this side of 6 minus, right? For our charge on that side of the compound versus a 2 plus charge on the left. So we want to have 6 plus on the left, right? So let's add another magnesium, see what happens. So that gives us 4 pluses. So we got to add another magnesium. Okay, just adding a bunch of magnesiums until we get the correct ratio here. Now you can see that on the left side, we've got 6 pluses for all of these. That's going to cancel out with our 6 minuses, right? So when we write the formula for this compound, we're going to write Mg. How many Mg's do I have? Yeah, I have 1, 2, and 3. So 3 Mg's, Mg3, and let's color code this. And how many PO4s, or phosphates? Yeah, 2, 1 and 2. 2 phosphates, so PO4 And now I need to put a 2 down there. Why am I not putting the charge? Oops, let's make this blue. Why didn't I put the charge? Well, yeah, now this is a neutral compound, right? That was kind of the point of them bonding together. They want to be neutral. They want to be, they want to have no charge, okay? But we do need to indicate how many of each ion it takes in order to make that neutral compound. And in this case, the only way to get a neutral compound out of both of these things bonding together is to have them bonding in this ratio, where we have 3 magnesiums to every 2 phosphates. Okay. All right, kind of weird. Let's try one more. So we got sodium, which is Na1 plus, right? It's in the first group of the periodic table. And then we've got this thing called carbonate. Carbonate. Let's see, what's carbonate? Carbonate's another polyatomic that you are going to need to memorize, right? It's on your list. Oh, I also meant to mention, I can't remember if I mentioned it at the beginning of the video or not, but this chart should look familiar. It's on your unit conversions handout that I gave you at the beginning of the quarter. All right, but carbonate was CO3 2 minus. CO3 2 minus. All right, so looking at this, we've got our 2 minus charge over here and a 1 plus charge over here. So when these two bond together, our job is to figure out, well, in what ratio are they bonding together? All right, so we've got 1 plus versus 2 minus. So what do we need to do? Yeah, we gotta add another 1 plus, right? So that these charges cancel out. And now we've got to represent that formula correctly with how many of each we have. Now we have 2 NAs, so we're gonna put a 2 there, right? 2 NAs, so we're gonna put a 2 there. And then we've got 1 carbonate, so there is an imaginary 1 there, but you don't need to write it out. You can just leave it like that. All right, so let's go ahead and name these real quick. So the first one would be ammonium nitrate. That's what you would see on a bottle of this in lab, ammonium nitrate, right? Just saying the polyatomic ion names. Over here, we've got magnesium. You're going to name the cation first, magnesium phosphate. And down here, we've got sodium. Again, cation first, carbonate. And then I'll label this cation. And this is a polyatomic. Polyatomic anion. Then this is just a regular cation, and this is a polyatomic anion. And this is just a regular cation again, and this is our polyatomic anion. Okay, remember cation, anion, cation, anion. So that's how you would name those. Very important to name. All right. And now I want to take a little bit of a side note or a detour. I want to show you an easier way to do this. And it's called the crisscross method. So let's go over here and we'll label this crisscross method. So what's the crisscross method? So the crisscross method is an easier way or a quicker way, now that we know how this actually works, of figuring out what the formula is for any ionic compound, okay? So if we have something like magnesium and chlorine, and we want to make the ionic compound formula, what we're going to do is we're going to figure out, all right, well, magnesium has a 2 plus charge when it forms an ion, right? It's in the second column on the periodic table. Chlorine has a 1 minus charge when it forms an ion. And now what we can do to figure out the formula for this ionic compound is we can just take each of these and flip them or crisscross them. And that's going to give us how many of each atom or ion are in our formula. So let me show you this step by step. So what we're going to do is we're going to take this 2 here on magnesium, not the plus sign, because remember, our goal is to write the formula And the formula is going to be neutral, right? It's a neutral ionic compound at the end of this. So we're just taking the number 2 there, and we're popping it down by the chlorine. So like this. Okay, so far that's what we have. We're not done yet. All right, now the next step is to take the 1 from the chlorine and pop it down over by magnesium. Okay, remember, we're not taking the charge with it, just the number, 1. And this would go here. And in fact, actually, let me do that in a different color. Let's do that in green. And this would be our formula for when magnesium ions bond with chloride ions. So how does this crisscross method work? I'm skeptical. So looking at here, the way that we used to do this in the last couple of videos is we said, okay, this and this charge, whoops, missing my 1 there. Those 2 charges are not going to cancel out, right? So what do I need to do? Well, I need to add another chlorine. Right? And when I do that, I'm going to be left with 1 magnesium and 2 chlorines. Are these the same thing? Yeah, they're the exact same thing. So let's try another one. So magnesium and phosphate. So this is the same one that we did over there. Okay. All right, so what we're going to do, remember, with the crisscross method, we're going to take this number here and we're going to pop it down below, just the number. And then we're going to take this number here and we're going to pop it down below, just the number. And what are we going to be left with? Mg, green arrow, 3, right? PO4, blue arrow, 2. Crisscross method. We took those numbers, right, and we crisscrossed them. Did we get the same thing? Yeah. Mg3, PO4, 2. Crisscross method. It always works, okay? It always works. Let's try it with sodium carbonate, just so you believe me. So sodium, Na1 plus, carbonate, CO3, 2 minus. All right, we got to do the crisscross method. So we'll take the green, the 2, and pop it over there. That's Na2, 2 NAs. And then we've got CO3, our other ion, and we're going to take this 1 and pop it over here by CO3. So that's just 1. And now remember, if it's just 1 down there, you don't have to show it. So let's do a cleanup step, Na2CO3. And let's see, did we get the same thing? Yeah. Looks a little different because I didn't put the parentheses there. Remember, they're optional if you just have a 1 here. Okay. But that's the same thing. All right, now, so far we've been practicing these formulas, writing these formulas, with atoms that only form one type of ion, right? So when magnesium forms an ion, it's always going to form a 2+. When chlorine forms an ion, it's always going to form a 1-. But some atoms, specifically transition metals, the short columns on the periodic table, many of those can form more than one ion when they form an ion. So for example, iron can sometimes be 2+ and sometimes be 3+. They're always cations, okay? So all of these are metals, so they're forming cations. But they can have variable charges, right? The magnitude of those positive charges is different. 2+ versus 3+. Some can form 1+ versus 2+ versus 3+, and so on. So sometimes we need to figure out what the charge is of one of those atoms in a compound. So for instance, if we have FeCl2, first off, right, let's think about what this is. There's no number here, so we're going to assume we only have 1. So that's 1 iron bonded to 2 chlorines. Okay. Now for chlorine, does chlorine form different charges? No, right? Chlorine always just is going to form a 1 minus charge because it just wants one electron. Okay, chlorine is not an exception. So always going to form that 1 minus charge. So chlorine, we know the charge on chlorines. They have 1 minus charges. But notice we have 2 chlorines. So if we have 2 chlorines, each with a 1 minus charge, and let's actually just write this out. If we have 2 chlorines, each with a 1 minus charge, and I know that because iron is a transition metal, it's one of those metals in the middle of the periodic table in the short columns, and I know that those transition metals, they're tricky, they can form more than one charge. I can figure out what the charge is on that iron by looking at those chlorines and kind of working backwards. So if the overall charge on the right side of this compound is 2 minus, what does the charge on iron have to be in order for this compound to be neutral? Which it is, right? There's no charges written there. Yeah, this has to be 2 plus, right? So for this example, FeCl2, so for this compound, FeCl2, the ion that is bonding to our chloride ions is an iron 2 plus ion or cation. So Fe2 plus. Okay, so my answer is 2 plus. All right, let's practice this because I know it's a little weird. So copper and oxygen. So Cu is copper. And it is a transition metal, right? When you look on the periodic table, copper is one of the short columns in the middle. It's one of our transition metals. So it can form what's called variable charges, right? Variable charges. They can vary. They can change. So copper can form different charges. But oxygen, when oxygen forms an ion, what ion does it form? Yeah, a 2 minus ion. Always, right? When oxygen forms an ion, it's always going to form a 2 minus ion. So copper, if oxygen on the right has a 2 minus charge, what does the charge on copper have to be? Yeah, 2 plus, right? Because they've got to cancel out. All right, same idea here, but let's kind of draw this over here. So we've got SN versus 2 oxygens, and I'm just going to write, whoops, 2 minus, what am I doing? 2 minus. I'm just going to write both of those oxygens out, okay, because it says I have 2 of them. So I have one tin, this is tin, and it's a transition metal. So we don't know the charge on tin, but we know that on the right side of the compound, we've got an overall 4 minus charge. So what does the charge on tin have to be? Yeah, it has to be 4 plus, because those charges have to cancel out. All right, now we've got lead and chlorine. Lead is our transition metal here. Now for lead and chlorine, we've got Pb, and it looks like we have 2 chloride ions. So remember, when chlorine forms an ion, what ion is it going to form? Yeah, 1 minus because it's in the 7th column on the periodic table, tall column. It's going to want to gain that 1 pesky electron. So if we've got 2 1 minus charges for an overall 2 minus charge on the right side, what does the charge on lead have to be? Yeah, 2 plus, right? Gotta cancel out. So you're kind of working backwards. Which charge do I know? Which one's not ever going to change, right? And then work backwards to figure out what the charge on your transition metal might be. All right, now for transition metals, they have a special naming system, and it is a little bit kind of annoying to get used to it, but after a while it does become second nature. So anytime you have a transition metal in your compound, they can form variable charges. We need to know what ion is formed for these compounds. So, and the way that we do that is we name them in this kind of special manner. So the same idea as before, right? We're going to write the cation first, then the anion, and then we'll give it the ending plus IDE for the anion. Okay, so for example, right, for NaCl, that's sodium for our cation, chloride, right? Chlor for the anion, and then ide for the ending IDE. Kind of weird, but familiar, right? With these transition metals, it's very similar. You're just going to have an extra little bit in the middle. So for this first one, copper is a transition metal. It's also a metal, right? Transition metal. So remember, metals usually form cations. So this one's going to be our cation. And this one's our anion. And then I just want to make a note for myself that this is a transition metal, which means we have to indicate what charge it has. So this is the same one that we did above, so copper and oxygen. So looking up here, we said, okay, well, copper in this one must have a 2+ charge. And that's the type of ion that we have for copper here. So we would name this as copper 2 with a Roman numeral 2 oxide. And let's break this down a little bit. So this is our cation, right? Copper. We just label it copper, right? Just gets to keep its name. And then we have the charge in the middle here. The charge on transition metal cation. And then we list the anion as we always would, right? Oxide. All right, let's try this next one. I know it's a little bit weird. So this is tin. We're going to leave a space for our charge on tin. What's the charge on tin? Because remember, tin can form different charges depending on what it's bonded to. And then oxide for that oxygen at the end. So what's the charge on tin in this compound? Well, luckily we just found that. So that's 4+. 4+. So you're going to need to give it the Roman numeral 4, which is IV. All right, and then the next one is lead, right? Just naming our cation. But it's a transition metal, so it can form variable charges. So we need to include the charge on that lead. And then we'll name the next part is the anion, and that just gets the IDE ending, chloride. All right, so what goes in the middle there? Well, what's the charge on lead? It looks like it's 2+ here. We just found that. So it gets a 2 for the Roman numeral. Right? If it was a 1+, it would get a 1. If it was a 2+, it gets a 2. If it's a 3+, it gets a 3 in Roman numerals, and so on. So this is how you would write the names of these ionic compounds that are formed with transition metals. All right, so I think the most important thing with ionic compounds is to remember that ionic compounds are formed between a metal and nonmetal. You can have polyatomic ions, right? And they would just be your nonmetals. But if there's a metal in there, you're going to have an ionic compound. If a compound only contains nonmetals, right? If it's only nonmetals, then that is a covalent compound. And those are very different. They behave differently. So we'll talk about those in the next chapter.